Hello everyone, let's try another one in the variant series. So, this one is called Gas XV. This is from the Missing Deck site. This is one of their easier variant Sudokus. And it says each row, column, and box must contain a complete set of 1 to 9. And killer cages, digits within cages, marked by dashed lines, cannot repeat within the cage and must sum the number in the upper left corner of the cage. What that means is this 10 cage with 3 cells in it, these 3 cells sum to 10. These 3 cells also sum to 10. These 3 cells sum to 15. And then XV, digits separated by an X sum to 10. If they're separated by a V, they must sum to 5. That means these 2 sum to 5, these 2 sum to 10, etc. Digits not connected by an X or V may or may not sum to 5 or 10. What that means is that there's no negative constraint, as it also says in the rules. These 2 cells could sum to either 5 or 10, even though they're not marked. All this is saying is these 2 cells must sum to 5. It doesn't necessarily imply that these don't, or that these do. It could go either way. And then we have Kropke dots. Digits separated by a white dot are consecutive. So what that means is these 2 have to be consecutive. So if this was 4, then this could be 3 or 5. That's how white Kropkes work. No negative constraint applies. What that means is there could be instances where these might sum to 10, or these could sum to 5 and also be consecutive, even though there's not a V or a white dot. So this could be 2 and this could be 3, or vice versa. So, with all that, let's look all this in. Conflict checker off. So theoretically, I can do that, and I actually have to look without it telling me. And with that, okay, let's restart and let's keep going. So what I see when I look at this grid, I think every single cage sums to either 10 or 15 and has an X or a V marking within the cage. This is a 3-cell cage to 10, so's that one. Whoops. And that one. And that one. And that one, and indeed that one. And this one, which I can't isolate with the other ones. But what that means is I know a bunch of 5s. Because all these 3-cell 10 cages with V's that sum to 5, well, I know this is 5. Because they add to 10, 2 things that sum to 5 mean I have these 2 cells add to 5. 5 from 10 leaves the 1 cell that does not have a V on it. That's a 5. So this cell operates the same way because these 2 cells add to 5. So that's a 5, as is that cell, and that one, and that one, and that one. They're all 5. And that gives me a lot of 5s in this grid. I have 6 of them already. Let's see. There are some 15 cells, or 15 cages like this one, where these 2 cells sum to 10. 10 from 15 is 5. So in a similar fashion, I know that's a 5. And that's a 5. Let's see, is there another 15 cell that a cage that I'm missing? Yes, this one. These 2 sum to 10, so that's a 5, and just like that, I have all 9 5s in this grid. This is a 5. It's consecutive to 5, but it also is on a V. That means this cell and this one add to 5. So this cannot be greater than 5. It must be less than 5. The only cell that's less than 5 and also consecutive to it, that's a 4 by write-in. That's a 1 because 4 plus 1 is 5. This is now 9 because 9 plus 1 is 10. And so what we have, these are 10. This is now a 2-3 pair in some order. Because the things that sum to 5 are either 2, 3, or 1, 4. Well, it can't be 1, 4 because of this. So these are 2, 3. This x now cannot be either 2, 3, or 4, as it's constituent pairs of digits. So if you think about pairs of digits that add to 10, 1, 9 works. It can't be 2, 8 because I've used the 2. It can't be 3, 7 because I've used the 3, and it can't be 4, 6 because I've used the 4, and it obviously can't be double 5. So these are a 1, 9 set. So I have a 1, 9 set, a 2, 3 set, a 4, 5. What I'm still missing are 6, 7, 8, and so these are 6, 7, 8 to fill out the row. Now, let's see. These two sum to 5, but they can't be 1, 4 because this one's already used 1, 4, so these are a 2, 3 set. And if this is 2, that's 8. If this is 3, that's 7. So that's 7, 8. Let's see. This is consecutive to 5, that's also on a V, so that's a 4. This cell is a 4 for the same reason, but that one's a 4. So that's a 1 by acclamation. This is a 2, 3 set. Let's see. If this is 6, that's 4. If this is 7, that's 3. If this is 8, that's 2. So 4, 3, 2, like that. Let's see. This can't be 1 or 4, so this is a 2, 3 set of things that add to 5. And that's a 2, 3 set, so nothing else can be 2 or 3. So these are not 2, 3, or 5. So we're down to 1, 4, 6, 7, 8, 9. Well, this one, because it's part of a 6, 7, 8 triple in box 7, can't be 6, 7, or 8. And the same goes with that. Now, that eliminates a lot of things. If this is 1, this can only be 9. If this is 4, this is a 4, 6 set. It's a 1, 9, 4, 6, or 9, and this is 1. Let's see. This is part of the cage. It sums to 5, but it can't be 1 or 4, so this is a 2, 3 set. See, this is 2 or 3, so this can't be 2. No, this can't be 2 or 3 because these sum to 5, so this is a 1, 4 set. If this is 4, that's 6. If this is 1, that's 9. right? This 2, 3 tells me this is a 1, 4 set. And 1, 4 pairs with 6, 9 on an X. This 1, 4 tells me that's a 2, 3 set. Now, if this is 2, then this is 8. If it's 3, that's 7. But I also look at this 4 tells me that's a 1. And so that's a 4. So this is not 4. Whoops. Let's see, 2, 3, 4 here. So again, that has to be a 1, 9 set to sum to 10. So these are not 1 or 9. There's 6, 7, 8. So's that, and ironically, so's that. Now, this 1 tells me that's a 9. And so that's a 1. This 2, 3 says nothing else in box 3 can be a 2 or a 3, so these two are some fashion of 6, 7, 8, or 9. Except that's not 9. This one, I think, could be anything, which is moderately annoying. But actually, I've determined, haven't I, that that has to be a 9. It can't be anything else. Oh, and I could have gotten that was a 9 because that was a 1. But be that as it may, 1, 2, 3, 5, 9 says I need 4, 6, 7, and 8. So let's see. This one cannot be 1, 2, 3, or 5. So this is 4, 6, 7, 8, or 9. And then get rid of 4. This is 1, 2, 3, 4, 5. This is 6, 7, 8, or 9, but get rid of 9. Let's see. Box 6 might be a little more helpful. I have a 1, 4 pair and a 2, 3 pair already in along with 5, so I have 1 through 5 inclusive already placed. 6, 7, 8, 9 are yet to be placed. This is not 9. This isn't 9 either. So 9 is forced in one of these two. That's about all I know. Well, wait a minute. Column 7 has a 2, 3 pair and 1, 4, 5, and 9. So this is the other 6, 7, 8. Part to complete the triple in column 7. Not like that does me a whole lot of good. Now, these two cells. Wait a minute. This is part of the thing that sums to 5. This can't be 9. 9's a lot greater than 5, so that's a 1 by force. That's a 4. So that 4 tells me this is not 4. 2, 3 on a V has to be joined with a 2, 3. That's a 2, 3. That's a 2, 3. set. 2, 3 on an X is joined by 7 or 8. 2, 3 here tells me this is a 1, 4 set. 1, 4 on an X is joined by 6 or 9. This 1, 4 pair says nothing else can be 1 or 4. See, this is 6, 7, 8, or 9, except it is at 9. Let's see, I now have a 1, 4 pair, so this can't be 4. 1, 4, and 2, 3, and a 5, so I need 6, 7, 8, 9 there. And down here, except this can't be 9. I think could be anything now. Let's see. I have a 2, 3 pair, and a 6, 7, 8 triple, and a 5. So 2, 3, 5, 6, 7, 8, 9 are already placed. These two, ironically, end up as a 1, 4 set. And this is on an X. That's 4, this is 6. That's 1, this is 9. This can't, oh, and the 1, 4 pair also told me this can't be 1. And I bet you dollars to donuts this is 6, 7, 8, or 9. Yep. Let's see, 1, 4, 9 tells me this is 9, 6, or 1. So this is 1, 6, or 9. The only thing, 1, 9 is a complementary pair, and the 4 pairs with 6. Except 6, 7, 8 triple tells me this can't be 6. So this can't be 4. That's now 1, 9. That 1, 9 looks down here. That's a 4. Because it can't be 1 or 9. Okay, that's the other 2 or 3. Finish out the pair in box 7 and the lower end of this grid. Okay, so I have 4, 5, 1, 9. I need 2, 3, 6, 7, and 8. Well, this can't 2, 3, 6, 7, 8 to fill out row 9, except this one can't be 2 or 3 because there's a pair in there. So this is 6, 7, or 8. I now have a triple. That tells me this is the other 2 or 3. So I've got a 6. This is going to end up being 6, 7, or 8, isn't it? Yeah, and so's that. Okay, so there's some relationship among the digits that I don't know yet. Oh, this 1 has told me for ages that's a 9. So that 9 says this is not 9. The only place left for a 9 in box 2 is here. And that 9 I could have told you from this 10 clue. Let's see, 5, this has to be 4 or 6, but it can't be 4, so this is 6. And this one to be consecutive, that must be 7. And 1, 4. Well, this isn't 6 or 7, so that's 8. And the 1, 4, this is now forced to be 9 because it can't be 6. That's on a V. And 9 is on an X with a 1. That pairs with that being a 4. This 4 comes back down here. That's a 1, that's a 4. That 1 is on an X, that's a 9. This is not 6. Oh. This can't be 6 either, can it? It's not paired with 4 on an X. Let's see. This 8 on an X tells me that's a 2. And by acclamation, that's a 3. 3 comes back up here. 2. That's a 3. That's a 2. That's a 3. Look, that's a 2. That's a 3. And I get a party for 3 in the corner. 2, 3. That 3 comes down here. 2, 3, 2, 3. 2 is on an X. That's an 8. So these are not 8. Let's see. The only place for a 4 in row 1 is here. That's a 4. Because nothing else can be. No, I thought I was going to get somewhere with... Okay, I feel like I'm missing something. Oh, this 7 tells me that can't be 7. It's not 7 either. Wait a minute, this can't be 6 because that doesn't have 4 as a possibility. So that's down to 8 on an X. So that's a 2, that's a 3, and I'm going to get rid of a bunch of other ones because... Or so I thought. Oh, this 4 tells me that's a 1. So 9, 1, 9. This is not 9. That's not 9 either. Let's see. Oh, this 7 has now told me that's an 8. That'll be the key to get rid of a lot of these other things. This 8 tells me that's not 8. This 8 tells me that's 7. That's 6. That's 7 to finish the column. 8. 6 to finish out that row. This 8 tells me this is not 8, so that's 6. So this is not 6. 7, 8 pair looks at that. That is 6. These are not 6. That 6 looks over here. Neither of these are 6. See, this 2 looks up here. That's a 3. 2. This 8 looks up here. 7. 8. 7 looks down here. That's 6. This 8 tells me these are an 8. That 6 now tells me 7, 8, 7, 6. 8 to finish that row. Piggybacks up here, 7, 8. That 7 piggybacks down here, 6, 7, which now piggybacks up here, 8. 7, that 1 tells me that's a 4. Ah, I got too many 8s in here. Let's see, that 7 tells me that's an 8. That's 6. That's an 8, and that's an 8. Yeah, I just mistyped. That's it, but yay.